Welcome to the joy of coding.
Hello? 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 Can you hear me now? Oh boy, failed to do a little pre-flight check there on the audio. Hopefully you can hear me okay. Hi everybody. Let's try that again. 1 second. Whoops.
Welcome to the joy of coding.
Hello and welcome to a kind of glitchy episode of The Joy of Coding. It's episode 139. Hello. How are you? I hope you're all right. This episode, I started it a little incorrectly at first. I apologize. And now I've realized that I need to get a little bit of extra information on my tablet so I can trigger sounds when I need to and not have to do it from my desktop. So 1 quick second. Bear with me. How are you? I hope you're doing well. I hope you had a good week. Today, as usual, we're going to be hacking on Firefox. Come on, wake up. We're going to be hacking on Firefox stuff today. It's a little bit of a continuation from last week because a lot of what we're covering is the same stuff, but just hopefully a little bit faster. Last week was a little bit trickier. Had not as much information as we do now, which is nice. So there's been a little bit of an evolution in terms of my learning. And I'll share what I mean in just a second. So let me, oh, great. Near 94 says, yep, we can hear. That's great. So I've switched to my screen. Here's my screen. Hello. And here is today's agenda. So today is May 16th, 2018, episode 139. A reminder, it should be obvious based on the beginning of this episode that no plan survives breakfast. A lot of this is going to go wrong. None of this is pre-planned really beyond just general bugs I want to work on. I don't have pre-written solutions on, I don't have a great bag full of code already written that I'm just going to be typing in like you might see at like a conference or something. This is all happening on the fly, making decisions, trying to fix bugs on the fly. So things could go wrong. I might get stuck. I might not understand stuff. That's life. That's also real software development, and that's what I'm trying to capture here. Before we go in, I want to give a plug for the episode guide. The episode guide is a viewer-driven episode guide, and before I do that, though, I should probably tell you how to get to the agenda here, because it doesn't help that you can see these links if you can't click on them. So if you're watching this on Air Mozilla, old Air Mozilla, somehow, scroll down to the additional links section because there should be the links to the agenda there. If you're watching this on new Air Mozilla, check out the handout section, which is on either side of the screen. I have no idea actually where it is in relation to the camera. If you're watching this on Twitch, I'm about to drop the link to the agenda in the Twitch chat. Coming at you. Here you go. Boom, there's the agenda. And if you're watching this on YouTube, check the video description because the link's in there. And I should also point out that there is a link in all those places to rate this episode. Once the episode is done, I'm just going to drop it in for the Twitch people. You can let me know what you thought. Each episode has one of these forms, or most episodes have these forms. I read everything that comes in. It helps me out, helps shape the episodes. Give me your feedback. I'd love to hear from you. The episode guide is completely viewer-driven. Viewers just like you help to make it happen. I've done very little in order to make it happen. I just opened a repository and people send patches and I merge them in. If you're not sure what I just said with respect to repository or pull requests and merging, here's a guide for creating pull requests in case you want to contribute to the episode guide. Because if you go to the episode guide, we've got episodes leading up to, let's see, let me pump up the font. We got episodes all the way up to 136, it looks like. And so we're a couple episodes behind, and if you want to help out, you can send in some extra episode notes or new episode notes, or you can even augment older episodes if, for example, I make a mistake and you want to put in a correction, or maybe you want to link to some stuff I talked about, or you want to link to alternatives for things I tried, that sort of thing. That's perfect fodder for the episode guide. and they don't have to be long. Like some of them just contain. This is actually what a good chunk of them contain is like a link to the video, a link to the Evernote agenda, and then some of the topics I cover, including links. So do check it out if you want to check out the episode guide. Also, I'm doing transcriptions. I've fallen a little bit behind on this, but I've been trying to do automated transcriptions using Mozilla Deep Speech to transcribe the episodes of The Joy of Coding without having to go through like Google services. I'm trying to like do it by myself. And one of the things that you could really help out with is by going to amara.org and helping me transcribe some episodes. So there's a spreadsheet here that shows which episodes are done and ready to be, they've been auto-transcribed and they're ready to be like corrected because the auto-transcriptions aren't perfect. And so a bunch of the episodes are done, a bunch of them still need work or are like in progress. I've fallen really behind here. I think there's a big gap. There are a bunch of episodes that need some polish, but a good chunk are done, and if you want to submit some corrections to the transcriptions, you can do that on amara.org, and then after you create your account, you can log in and then click on those links in the spreadsheet if you want to submit some corrections. Okay, well that's all the plugging I think I want to do. Let's get down to business. We're 8 minutes in. I just want to make sure everything is working. You can hear me. Yes. I can play sounds maybe. Oh boy, come on. Yeah.
I don't think so.
Great. Let's see what we're doing. Well, the first thing I want to do actually is review a patch or a series of patches. It's sort of an addendum on the same series of patches that we reviewed last week with the LRU cache. If you're not sure what I mean, you should watch last week's episode because we reviewed these first couple of patches. And now we're reviewing 3 more because these patches landed and then it all got backed out again because of an invalidation bug. And so Doug Thayer, who is working on this bug, he has requested review on some fixes for the invalidation bug as part of this series. So I'm going to review that today. Let's get started. So what's the invalidation bug? Well, I can describe the behavior of it. If we're using the LRU cache, that means for tabs that we've just switched away from, we keep the rendered layers cached in the background so that we can switch back to them very easily, very quickly without having to force a repaint. One of the problems with that though is oftentimes pages in the background update themselves and they'll change their appearance, and we won't repaint in those scenarios. We don't handle those scenarios. So if you switch back to that tab, until we trigger a repaint, we ourselves trigger a repaint, the tab will show stale content. So that's the bug. And so let's see what solution Doug's come up with here. Let me pump up the font a bit. So the first thing I'm going to do is I'm going to read the commit message. He says, well, this is going to force a paint when switching to a loaded tab. Well, that's good. This is fairly straightforward, other than the fact that the nomenclature gets a bit awkward with the aForce parameter on the force paint methods. I'm not sure which direction to go with this. aForce seems a fairly intuitive name for what we want, and I'm kind of inclined to say the existing force paint mechanic should be renamed to something like paint with interrupt or paint with priority. Okay, that's interesting. So, let's see. What's he doing? So he's touched a number of files here. He's touched the async tab switcher. He's updating the tab parent interface. He's updating some of our inter-process communication stuff. 2 IPDL files being updated. Those are the inter-process communication protocol definition language files. So we should look at that. And because he updated those, he had to update the associated actors, and then he's changed some stuff inside the remote browser binding. So that's what's going on here today. Let's start with the interface changes. So what he's done is for tab parents, he's added a force paint method that will send a message to the child ensuring that they paint as early as possible. This will send the message to paint even if render layers is already true. Okay, so I see what he's trying to do. He's making it so that even if in the background we already have the layers, if we already have the layers, if you switch to that tab, we schedule a paint. Okay. Okay, so let's see. He updated the tab parent XPIDL binding. I'm assuming, yeah, inside the remote browser binding, he added a force paint method. And the way that works is it checks to see if we have a tab parent. If so, it will call the force paint method on it. So that's pretty straightforward. And then let's take a look at the tab parent changes. He didn't need to add the force paint method because that's already done by a macro. So set render layers internal. So what's that? Okay. Oh, I see. So he's like factored out some common code here to render layers. Let's expand this code. So this used to be what we'd call, in order to tell the content process to paint, is we would call render layers. And what we'll do is we'll check to see if we already have layers and we're preserving layers. And then the last thing we do is we update the epoch and we send the layers. And the epoch is so that, because we're sending the message in two threads, one is probably less encumbered. In case JavaScript is running on the main thread, we can interrupt it in the content process. That's why we do that. So instead, we have this like set render layers internal enabled and then false. And what does this do? Enable and force. What I like to do with Boolean arguments, for Boolean arguments like this, I sometimes find it's clearer to do something like set render layers internal, a enabled, false, a force. I don't know why this isn't syntax highlighting properly. That's too bad. Up to you, but I think it'd make it easier to read and understand. Force. Enabled. So we're not forcing here, that's right. But when we force paint, same note as above. This might be easier to read as set render layers internal true, a enabled true, a force. All right. So in the event that we're forcing, okay, so we're adding a new argument here to set render layers, force the layer tree epoch. And this is the one layer on the main thread that we're sending to the main thread, and the other message, sorry, that we're sending to the main thread. Here's the message that we're sending on the force tab paint thread, the background thread, in the event that we want to interrupt JavaScript. Okay, so that all reads okay. So I'm happy with that. That file's reviewed. That file's reviewed. Done that. I can collapse this. This all makes sense so far. Pretty happy. And this, I'm fine with that. You have to add this. So on the receiving end, well, first of all, let's take a look at the interface, the IPDL file he updated here. So for a force, true if the child should force a paint even if it's already visible. Layers. So he was saying that a force is a good name for this, and that it kind of conflicts with this other force paint that we're doing over here. And force paint in this context for this one is when we're bypassing JavaScript. We're interrupting JavaScript that might be running on the main thread in the content process to say, hold on, paint, then continue your JavaScript. So he's saying that maybe we should rename force paint to like paint with interrupt. So an alternative here, because I have an alternative idea. We could rename force paint to either of your suggestions, or we could maybe rename the argument to do repaint, allow repaint or something to indicate that allow repaint is force paint but I think I like his suggestion better, naming it paint with interrupt or paint with priority. I do, however, think it might be better to rename force paint paint with interrupt paint with interrupt might be made clear with paint with JS interrupt. Made clear as paint with JS interrupt, or maybe paint. What's another good name? Paint. Paint while interrupting JS. Paint. While paint while interrupting JS. Spelled interrupting. Did I interrupt? Interrupt. Is that how you spell it? Yeah, interrupt. Yeah. Paint while interrupting JS. Paint while interrupting JS. I guess I should make I could make a call here. Paint while interrupting JS. I feel like maybe paint while interrupting JS is clearest. How do you feel about that? Paint while interrupting JS. Okay, so then he adds a force paint to the process hang monitor. So he's done the same thing up here, or down here he did to the hang monitor thread. That's force paint. It's already visible. Maybe a force repaint. Naming is hard. So he just passes this stuff along until eventually we get to where? The tab child. That's where the action is. All of that's plumbing. All of what we just looked at was plumbing, making it so that the parent can talk to the child and say, hey, do a repaint. So let's look and see where it receives that message. Hang monitor. This is all the plumbing. Oh, this is different. We hadn't reviewed this one yet. So on the child side, we received the force paint and we set a member to be that value. Force paint force. Yeesh. Yep. Probably should should rename one of these things before any of this lands. M force paint force. I don't think we need the yeesh. Yeah. Force paint force. Force paint force kind of sounds like a superhero group. I'm part of the force paint force. So what we do is we take a lock and then we get the variable, and then we ultimately call tab child. So we've added a new, right, okay, so that all makes sense. We're adding a new variable because if we get it on the right, if we get this on the force paint thread, we have to stash it away until we can interrupt JS. And in the parent side, we are adding a new, yeah, that's just plumbing. That makes sense. Bool, yeah, bool, yeah. Yeah, okay. So this is the interesting part. Tab child, force paint force. Receive the render layers. So in tab child, we have a couple places where I guess we already call receive render layers, and we say false. Right. Same note as above, Boolean arguments. It's a personal preference, and I'm willing to take pushback. It's not like Mozilla policy or anything. So if we're not forcing, so this is the interesting part. So we receive the message to render layers. So if we're not forcing and we are visible, then we say no op. Right. Otherwise, so this is where we would escape if we were already visible. Right, okay. So that's what we're bypassing. And then down here, yeah, okay, so this makes sense. I like it. I like the idea. I think it's just the naming. Structurally, this seems sound. I don't think it needs re-review, but certainly the naming needs to be worked out before this lands. If you end up renaming, right. So I like it. I'm gonna R plus it, because most of my, what I'm asking for is cosmetic, all cosmetic, and is really more about naming. So thanks. And then he's saying, oh, we missed a part actually. The async tab switcher. Yeah, so what he's doing is, whenever you request the tab, if the tab state is already loaded, if we already had the layers, and if it's a remote browser, that's when we force paint. I guess we risk the case, we risk showing a single stale frame, we still risk frame if the compositor is told to flip, if we flip the deck before the compositor receives the new layer, the updated layers. That's not an issue so much as a question. clear the cache layers on location chain. To avoid a flash to sale content, oh, we need to make sure we remove the tab from the cache if its location changes. Okay, so this is one way of getting rid of right. Okay, so if in the tab browser code, if we notice that the tab is what? What's the tab doing here? The on location changed. The location is changed. And if there's a tab in the tab layer class, then we cache, then we call cleanup tab after eviction. Oh, and that's in the first patch. Just gonna wait for this to load. Come on now. Hey, for people with like accents like mine that aren't Australian, if you want to know how to easily have a stereotypical Australian accent for one word, that word is razor blades, here's how you say it. You say, instead of razor blades, you say rise up lights, like lights. Rise up lights. So rise up lights. That's how you say razor blades with an Australian accent. Rise up lights. Or maybe it's lides, Lides, rise up lides, something like that. All right, cleanup tab. So what we do, right, we set it to unloading so that it goes away. All right. If it's in the background. That seems like it's okay. I think this makes sense. And then don't let the cache interfere with tab warming. While working to reproduce the stale content bug with tab warming, I realized on my work here it inadvertently clobbered tab warming by immediately calling the tab unload code. This wasn't necessary, and I didn't need to put the cache tab deactivation code in the unload method. Just seemed initially convenient. This should make more sense overall. Whoops. So I think he's like reverting something here. Let's take a look at his old patch. Oh yeah, he's added some documentation here. This is very nice. What does the documentation say? Based on the browser tabs remote tab cache size pref, we keep recently used tabs layers around to speed up tab switches by avoiding the round trip of the content process. This uses a simple array inside tab browser.js, which we examine when determining if we want to unload tabs layers now. This is still experimental as of nightly 62. Okay. And then what did he do during the unloading? That's this stuff, I think. Right? Where are we? Post? No, that's post actions. Where's unloading? That's unload non-required tabs. Request tab. Finish. Where is the part that he's talking about? Num warming greater than tab warming max. Num warming or num background cache greater than 0. So this is the part that he changed. Originally, he's doing this. And he's saying now, after we're done updating state inside the async tab switcher state machine, if the number of background cached tabs is greater than 0, deactivate cached background tabs. And that's go through the tab layer cache, and then for each each tab that isn't the requested tab, say preserve the layers but deactivate the dock shell. Okay, right, deactivate the dock shells. And if number of warming tabs is greater than the tab warming max, then unload the non-required tabs. And this is what we were doing before. Okay, that's great. Yeah, this does make more sense. Yes, you're right. This does make more sense. And I'm sorry I didn't catch it the first time around. Thanks. Publish. All right, so did my reviews there. Next, right, the empty binding thing. This is what we ended up finishing with last week. Excuse me, my back. Oh. Ow. Ow. Just gotta stretch. Gonna finish this mug of coffee. Hang on. One moment. I need to cool down my brain from that code review with some coffee. 1 second. Okay. Oh. That was not the best bit of coffee at the end there. Not sure what happened. Let's get right into it. Nasty. So what's going on? If you remember from last week, we had this like scroll bar binding that got removed, this XBL binding. The war on XBL continues, and if we look at the graphs, we're down to 194 bindings remaining, which is great, but we added this new empty binding, this binding called empty, and that's because if we remove it, then like there was a scroll bar binding, we removed it here. There was a CP startup, like a content process startup regression on Linux. As soon as we put back the an empty binding, doesn't have to be the scroll bar binding, just any empty binding, we fix the regression. But we still want to remove this empty binding. We have to figure out what is going on. What the dealio?
What happened? Hey, what happened?
So, yeah, that's the question. What happened? So I've got, let's see. Let's log into beast mode where I think I have a debug build of Firefox having finished up. Yeah, I finished building it. And so what I'm going to do is I'm going to run the CP startup test using RR. And let me just refamiliarize myself with the CP startup test. Process pre-launch. Right. The one thing I'm going to have it do is I'm going to have the content process before it runs, while it's running the process pre-launch. It sends this message, browser, child ready, right here. I'm also going to send like my child process PID, and that's services.app, what was it? Services.app.info process ID, I think. Services app info.process ID. Yeah. Services.app.info.process ID. And I'll have it dump that out so that hopefully I can find it. And I'll put some new lines around it and make it stand out more. I'll build that faster. And then we're going to run the CP startup test just once, but we're going to do it with RR enabled. Or we're going to try to do it with RR enabled. I've never tried this before to run it with RR enabled. We might actually have to hack around a little bit to make this work. Actually, yeah, like let me see here. RR usage. How do you use RR? You do like RR record and then path to application. I think that's what we're gonna do here. Is I'm gonna hack in the support for RR. There is the Talos runner. Talos like test or run tests. One of these things ultimately calls the executable. I'm just trying to remember what it is. Let's find it. Testing Talos. Not that. No, not the tests. It's like FF setup, and we like generate a command line. Run profile and a gecko profile collector clean ccov. Merge web server. Telling a profile instead of using the empty one. No, none of that. No. Config, is it config? Or we generate, no. Get a test, no. Get browser config, maybe. Get config, nope. Command line, that sounds more like it. No, that's for the Talos command line. Shoot. How about utils? I'm looking for, yeah, generate browser command line. This is the thing. Command args starts as the browser path strip. And so I'm going to modify this inside my virtual machine here. Testing Talos, Talos utils.py. So instead of just having the browser path, I'm going to say rr record and then that. I think it'll allow that. Maybe I should do this. It'll probably allow it, but I'll do that. And I think that will do the job. So if I do mock, oh, I also only want to do one run. Maybe 2 runs of CP startup. So CP start. No, that's not it. Is it test.py? CP startup. Yeah. So we're gonna do just 2, not 20. We're gonna do 2. And so now I do mock Talos test a CP startup. I'm not gonna profile. I'm just recording with RR. Let's see if it does it. Oh, I probably have to give it a display. And I think I've got a display at 1. Let me just pull up. No, I don't have a display set up at 1. Now I do. Yay! All right, so now run it. What? No such directory. Oh, I think I blew. Shoot. RM debug testing Talos vn. I killed it at the wrong time. RF. Get rid of that. Right. So what I'm hoping to do is that we can step through and try and understand like what it is that this test does in the content process bit by bit, especially when it comes to loading our empty XBL binding, so that we can try and by inspection, because like, well, while we're waiting for this, I'll show you some profiles because it's super confusing. Like I've got some profiles here in we'll look at the bad case and the good case. So this is the bad case and the good case. So I'll put the good case first. And the slowdown appears to be happening over here in when the content process is starting up. in the good case, we're taking. Oh no, I think these are the same URLs. Sorry. This is the bad case, I think. Yeah. So put good on left, bad on the right. Good is 265, bad is 273 milliseconds. That's how long this takes. And it's not really obvious where the time is going. One thing I noticed is that the tab child init stuff takes a bit longer, 35 milliseconds in the bad case, and in the good case, it's only 24 milliseconds. So, you know, we lost 10 milliseconds somewhere, and it's not immediately clear why. The problem is, as I dig deep into it, it just is like a bunch of this GTK stuff where ultimately we go down into GTK and we do stuff. And I'm not sure why it's taking longer in the bad case. And why does loading an XML document have anything to do with that? So I have a theory. And I'm looking to disprove that theory or prove that theory. Either will be fine. But I have a theory. My theory is, or hypothesis, I should say. And how's our test run going, by the way? So, oh, it's just starting. Cycle 1. What's going on here? Taking its sweet time, but that's because it's a debug build. So that's the first process that we want is 13980. Oh, I guess there were two, but we can take a look at 13980. That would be that's a good one to look at. So did it record it? PS. It did record it. Yay, we hacked RR into Talos correctly. So we're going to say RR replay, and we're going to attach to 13980. Yeah, like all this GTK stuff. What's my hypothesis? My hypothesis, we'll pump up the font here, is that when we are parsing the scroll bar CSS, because right now we've got it in this like empty dot empty binding. Let's take a look at where we added it. It was over here in this native scroll bars on Mac OS, and on Windows it's over here. Wait a second. Toolkit themes OS X global. Windows global. Where's the Linux one? So I'm just realizing this now. Where's scroll bar? What? Is it possible that Linux is using one of these? Let's find out. Scroll bar. Theme, no, .css. And we're looking at native scroll bars. So there were two. There's Zool scroll bars.css scroll bars. And that's used by shared non-Mac jar themes shared non-Mac jar inc. donmac.jar.inc is used by Linux. Okay, so the Windows one, wow, that's super confusing. The Windows one, global is, so this is what Linux uses. So that it needs the empty binding. Okay, so my theory is that Zool scrollbars.css, as soon as we observe the XML file, the Moz binding directive, that we like pause parsing the rest of the style sheet until later, until the XML has been parsed. And I'm not sure if that means that it happens on the main thread synchronously or if we go back to the event loop. That's what I kind of want to find out. But that's generally a theory, is that when we are parsing the scrollbar CSS for Linux, we delay parsing the rest of the CSS long enough, and maybe even go back to the event loop such that timing changes and we like resume the CSS parsing and application of stuff long after we resume the CSS parsing and application of stuff when we're less busy, so there's less contention and congestion. You know, one way we could test that maybe is by moving this rule, this Moz binding rule, to the bottom and seeing if the regression comes back even though we've got the binding if we put it at the bottom. So when is Zool scrollbars.css introduced? Scrollbars.css is used where? Here. We load the scrollbars sheet. And I think that was something that was like in here, wasn't it? Load scrollbar. Load scrollbar. No? Load scrollbar. No, we don't see it in here. Maybe it's in one of the other profiles I gathered. Load scroll. How would you scroll bar? What are these? What are you? Scroll bars sheet. Right here. When we create the load sheet URL scroll bar sheet s layout style sheet cache load sheet sync scroll in the cache we have the scroll bars sheet. So here we do enter this and then we load this. We load sheet URL, and in the bad case, we parse the sheet. Load sheet URL. Now in the good case, load sheet. Load sheet URL. Do they have anything about scroll bar? Not really. That's interesting. And then scroll bar. In the bad case, what's this? Not exactly what I wanted. part of me wonders if maybe... Well, this is all speculation. Let's see what our R says. We're going to set a breakpoint right here in scroll bar's sheet and see what happens. Let me pump up the font a bit. Bring this up so you can see it. We'll continue, see what goes on. Gonna open my pop. In Canada, we call this pop as opposed to soda. In the United States and maybe other parts of the world, they call it soda. Maybe in other parts of the world, they call it pop, but I know that in Canada, this is a pop. I'm having a pop. Not sure what it's like where you are, wherever it is that you are. Let me know in the comments. What do you call this fizzy beverage? This unhealthy carbonated beverage? So we're continuing here, waiting to hit this breakpoint. Okay. I'm going to pause for a sec. Did they find? Yeah, they found. Good. It was able to find the address for the breakpoint, so it's registered. That's good. So let's take a look at this load sheet URL thing. We will load the sheet. And let's assume that let's take a look at the stack. Load sheet sync. The parallel parsing code assumes that UA sheets are always loaded synchronously like they are here, and thus they'll never attempt parallel parsing on them. If that ever changes, we'll either need to find a different way to prohibit parallel parsing for UA sheets, or handle Moz, boolpref, and various other things in the parallel parsing code. So parsing mode, sheet parsing mode. What's the sheet parsing mode? Right. We're in safe agent sheet features. I believe, if I remember correctly. Yeah, safe agent sheet features. So we say load the sheet. And what's the third argument is principal. Use the system principal. Load non-document sheet. Did we hit our breakpoint yet? Nope, but we hit a SIGSYS. This is kind of cruft from our sandboxing. This is how we deal with that. Handle, SIGSYS, no stop, no print. And we just continue on. There's actually a really neat thing about hang on, I need to search my own tweets because I mentioned something about GDB. Yeah, Mike Conley saying these words, GDB. There was like a Control XA. Yeah. So this will allow us to... So we've hit our breakpoint. Let me show you something really neat. If you have been using GDB and you've been using it like this, this is going to blow your mind. Control XA. Ba-boom. Now I can I've got a breakpoint and I can hit next. And I've got a real UI here, which why is this not the default? I have no idea, but maybe that blew your mind. It sure blew mine when I saw it. So we're going to step into load sheet URL. We're constructing our URI. Okay. There is a URI. Zip archive is corrupted. We're going to step into here. Load sheet sync. Step into that. Okay, so We assert a bunch of stuff. If there is a sheet, we're gonna null out the sheet first. Like we have an out param here. I think this was the sheet that we're attempting to load. So we null it out first. We're checking the loading content policy. No, that should have changed. Is this a sync load? P sync load. It is a synchronous load. And that shouldn't have changed. So let's step into create sheet. Let's see what this does. We have something called msheets already. The sheet state is unknown. We have a URI. We are going to set the state to complete for some reason. First check the Zool cache. Is this a Chrome URI? Yes. Then we get an instance. Is the cache enabled? Then we ask to get the style sheet from the Zool prototype cache. Okay. Step out. How do I go up? How do I step out in GDB? GDB step out. Fin. I think it's finish. Yeah, finish. Okay. Finish. So we have a sheet. Right? No, we have null. It wasn't in the style sheet cache. If we don't have a sheet, then our per document complete sheets. What? We create a hash key, and we're gonna get the key. We're gonna try and get the sheet from this msheets thing. P complete sheet is null. And we didn't get it. So then we're loading the sheet, which makes sense. What just happened? Reverse next. So P sheet is null. P async load is true. Not async load, but a sync load. So if we're not doing a synchronous load, we would enter this branch without a sheet. We would, I guess, start to load the sheet asynchronously, but we can't do that, so we're going to skip this. Okay. We don't have a sheet, so we're going to skip this too. We do have a URI. Oh, how did we get here? All right. If not a sheet, what is a sheet? Where did a sheet come from? Oh, was a sheet. Oh, right. It's just a pointer to null. It's pointing at null. Okay. Because it's an out param. Right. So we need to parse it. If there's no URI, then we're going to skip that because we do have one. We get the URI. The URI is standard URL. So should still be our, this is just a sanity check, standard URL base URI is, yeah. Scrollbars.css. Okay. So next, what's a integrity? No idea what that thing is. All right, so we're going to construct a new style sheet. So let's step into that. We're gonna allocate. We're in malloc. We're allocating. Why are we allocating? Where are we? We're allocating because we're creating a new sheet. That's what's happening. Right, okay, so that's finish, 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 finish. And then we're gonna step into the construction of the sheet, and we just say like add sheet to minner. This, okay. What? I'm gonna set a, I don't think I did that right. I'm gonna set a breakpoint on style sheet. What is reverse next? Reverse next. Inside this thing. No, next. Step, fin, step. Then we create new style sheet info. That's interesting. Also, where are we? We're in Mozilla style sheet, style sheet. So I'm going to set a breakpoint in Mozilla. Oh, right. No. We're in the right constructor. Step. Yeah, we're creating a wrapper cache. Virtual thread. What? Where are we? Get current virtual thread. Current thread. Why? Where are we? I'm gonna finish out of this. Right. Media list. What I want is to break on Mozilla style sheet info style sheet info in the constructor. But that's not the right constructor symbol. Style sheet info. Mozilla style sheet. Mozilla style sheet info. Okay, break Mozilla style sheet info style sheet info. Right. So here we go. We're creating without, we create all this stuff. Server style sheet empty, consume, whatever, integrity, contents. Do all the stuff, and we just say that we constructed it. Okay, so that's not so bad, unless add sheet. What's add sheet? Style sheet. No, it wasn't style sheet info. It was minner add sheet. It is style sheet info. We're just adding it to M sheets. Okay. So I don't think we've actually done any parsing yet. All right. We set the URIs. So let's see what that's all about. All right, that looks okay. Should have a sheet. So we have a sheet, but I don't think we've loaded this sheet yet. And the state is sheet needs parser. So we've got a sheet, but we need to parse it. Okay, that's fine. So we haven't actually parsed it yet. Good. And then it's prepare sheet. So that sounds interesting. Now we've done creating the sheet. Oh, reverse next. Step into it. Step, 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 step. Yeah, here we go. Media list is no. Set media, set title. Set title, sheet set enabled, P. So I'm going to step into what set title is. Okay, we just do that, and then set enabled. Is P is complete? False, we're not complete. Okay. And then we return the media list matches. What is media list? Is nothing. Alright. What's the state? Needs parser. So we're not ready yet. We're gonna create new sheet data. I think what we really care about here is the loading of the sheet. But let's just take a look and see what sheet data is. Sheet load data. Pump up the font. Sheet load data. It's about whether, like, what loading state it's in. Should be no. Parent data pending children. Sync load is loading. Must notify. Sheet already complete. Okay. Anything in here about binding or XML or XBL? No? Okay. So let's skip over constructing the sheet data. Let's go right into load sheet. Need load data. That's going to assert a bunch of stuff. And loading, just a sanity check here. P Mozilla net NS standard URL A load data M URI. What is it? Yep, it's the scroll bars still. So we're loading our scroll bars. Is this a non-document sheet? Nope. So we're getting the integrity. P SRI metadata. What the heck is this? Unsure. Let's move on. Is this a sync load? PA load data M sync load. I think it is a sync load. Yes, we're loading synchronously. So that kind of blows away my original hypothesis, I think. It doesn't necessarily blow away, but like the loading of the scrollbars.xml or scrollbars.css style sheet appears to be synchronous. So I don't think we're going back to the event loop. That doesn't mean we might not make a bunch of stuff busy on different threads. So synchronous load. Better not be an observer. Sync loads can't reuse existing async loads. She needs. Right. So we're going to load the stream. We're going to predictor learn. Security flags for loading. PA is preload. false. Internal style sheet preload. Interesting. I wonder what that is. Just load it. So we load new channel with triggering principal. We read the URI. Oh, we skipped that part. Why? How do I go up? Reverse next. P a load data m requesting node is null. So there's no requesting load. Right, because it's the actual layout is asking for us to load this style sheet. It's not that there's a style node. Okay, so we're reading the URI. Result is okay. Nope. We couldn't read the URI for some reason from the URL preloader. Either we're loading something inside a document, in which case we should always have a requesting node, or we're loading something outside a document, in which case the loading principle and the triggering principle should always be the system principle. If the result is okay, do this thing. It's not, though. The URL preloader is not okay with it. So we create a new channel. And everything there is good. And then we get the stream. We're gonna open the, we're actually like getting the, loading the bytes out of this, the style sheet now. Get the stream. Good. That works. Force UA sheets to be UTF-8. Okay. And then we push the synchronous stream to a listener. Manually feed the stream loader the contents of the stream and then the parse sheet, regardless of whether this fails. Sheet complete has been called. Okay, so we're gonna step into this. What? Where are we? Right. Okay. So we are taking the input stream. Is the input stream buffered? I guess not. We get the content length. The chunk size is 2232. Chunk size. We get the input stream. All right, now we have our listener. We say on start request. What is the listener? Is the stream loader on start request. We get the channel for the request. We're getting the content length. If the length is greater than what we expect, we say we're out of memory. It's not, so we're good. We're good. So we when starting the request to load this off the disk, everything's happy, so we keep going. And then we start reading stuff. Where are we right now? We're in the stream sync load service. Okay. So we start reading. Read in. And this is when we're gonna like, well, no, we're just reading in the data. We're not actually like parsing the XML. We're still reading in the data, I think. Let's step into available and see what's happening. Available. If there's no stream, then we're done. Available, fill point cursor. On available. Available. All right. P succeeded. Available. P avail. Yeah. Result equals avail. So I think we loaded the file. So the red count is 2232. That's how many, I think, bytes are in the CSS file, I think. And then, oh, there's someone saying something in live hacking. They're saying they call it Lask with 2 dots over the A. In Swedish said like the A in bad Lask. Okay. Oh, 2 dots over the A. Yeah, I know that thing. Or otherwise usually soda or like Coke or Pepsi or whatever. And then Smurf D's mind was blown. That's great. So Smurf D was responding to my question of like, what do you call this in your country? And apparently where Smurf D is, Lask, which I guess is in Sweden. So I'm going to enjoy a sip of my Lask. Delicious. So we didn't fail to read stuff. And we didn't go overboard, so we do have data available. What happens when we have data available? Let's step inside. We check the status, and then we read the segments. Input stream, read segments from the stream loader. We're in buffered streams. We're just reading. We're just reading. I thought, okay, maybe we're copying stuff into memory, having read it off the disk. 2232 buffer. Yeah. Inside the buffer, we now have our. All right, we have our CSS file. That's good. We didn't fail. And we go back to the top of the loop. See if we're done. The base stream is closed and break from there or something. We didn't fail, so we stopped the request. So we've successfully loaded stuff, the CSS file off the disk. Woo! We're going deep, and I also have to end the stream in like a couple of minutes, but let's see if we can get a little bit further. So decode the data. This is the interesting part, I think. Verify. We're going to verify the sheet is ready to parse. What does that mean? Sheet load data wasn't canceled in the interim. If there's no document, or it's not a document sheet, or if it failed, or if there's no channel, get the original URI, get the principal, and we make sure we can get the principal. We set the principal on the sheet. It's not an HTTP channel. Get the content type, and the content type should be CSS. Text CSS, yeah, right there. You can't see where I'm pointing, but it's right there. So we'll enter this block, or we'll skip this block, I should say. Get the integrity. It's apparently empty. We get the load info. We're doing some security stuff. Okay. Return okay, parse sheet. What? Where are we now? So all is okay. The bomb handling has happened. We still may not have an encoding if there was no bomb. And sure, we have one. So we have no encoding before. And now we have some encoding. Encoding? Sure, UTF-8. And now we're going to parse the sheet. And, oh, so loading it was synchronous, but we're allowing async to be true right here. So maybe parsing it can be asynchronous. Very interesting. Let's step in here. Come on, get to the parse sheet part. Yeah. Parsing it. If we're gonna parse sheet with servo. So we're gonna step we're gonna get into some Rust code in a sec. I think. Being parsed. Is this a sync load? In some cases, like inline style and UA style sheets need to be parsed synchronously. The former may trigger child loads, the latter may not. The former may trigger child loads. Inline style and user agent style sheets. The latter. Allow async. So is this a sync load? PA load data. I think it should still be a sync load. That's true. So we will enter this block. So we're going to parse the sheet synchronously. And what's the current line number? A load data M line number should be 1. Okay. PA bytes 2232. Oh, those are the actual bytes of the CSS. Okay. And the length is 2232, right? All right, let's parse the sheet sync. Get compatibility mode. P-compat mode. Full standards. And we're going to say construct that. And we're going to say servo style sheet. Parse. And now we're in Rust. Oh my goodness, what are we doing? You know, I actually don't think it's the parsing of the CSS, because we're parsing it synchronously. I mean, I should double check this for whenever we when we take the empty binding back out, but I would suspect no matter what, we're going to be parsing the CSS synchronously. There's no stopping that. Is what it looks like. Maybe style sheet loader. Here's the thing I want to know. When do we reach the point where we load the binding? NSXBL service.cpp. Load binding. Load bindings. I'm going to create a breakpoint there. NSXBL service load bindings. And when am I? 574068, just in case I want to come back here. Let us actually continue and see where we get. Okay, I'm going to disable this breakpoint. 574068. That was where we were. Let me put that in here. Let's see whenever we load the empty binding. Oh, we never got there. We never got there. XBL, is there a load binding? ns xbl service.h. Binding. Get binding. How about get binding? Reverse continue. All right, I'm going to stop this episode in about 30 seconds because I got a meeting to run to. Wow, this is taking a while. Okay, so I'm going to continue this investigation on my own. I'm sorry I'm not going to have it recorded, but I'm going to keep digging, and we'll see how we do. Not bad. For this episode, we got a code review done, and we did kind of a deep dive here with RR. We were able to hack RR into Talos, and we're examining a recording. That's pretty exciting. We'll see what I come up with further digging. Hey, thanks so much for watching episode 139 of The Joy of Coding. I hope you found that enjoyable. Let me just switch to this view. Yeah, that's it. I'll see you next week. And there's no episode, I think, the week after that or the week after that. I'm not entirely sure, but I'm going to have to skip. I'm going to be traveling. I'm going to have to skip an episode in one of these upcoming weeks. I'm not sure what it's going to be, but we'll find out soon. Take care. Have yourselves a great week. See you next week. Bye-bye.
The joy of coding.
See ya.